Welcome back, guys. So we've had Chris on many times before, but he's back to talk about humidification. And AprilAire has a technology. They have a couple of new humidifiers. One's fan powered, one is got a bypass on it. It's an evaporative style humidifier, but there's a new technology that helps save water. It's not trickling down the drain constantly like the older traditional style humidifiers did. So we're going to talk to Chris about this technology and about humidification in general coming up on this podcast. This is the HVAC Know-It-All podcast. I'm your host, Gary McCreadie. This podcast is sponsored by Cool Air Products, Master, Cintas, and SupplyHouse.com. Go to the show notes and click on the links to check these guys out. All right, Chris, I'm glad you're back. It's been a while since you've joined us. I don't even remember what the last thing we talked about, but it was something probably under the realm of indoor air quality. Today, we're going to talk about some humidification and some new technology that also saves water as well when you're using like traditional humidifier that's evaporative. You know what I mean? Of course, you know what I mean. You're the expert at this. So where do you want to start with this, Chris?
Well, first, thanks for having us back. We're grateful for the opportunity to partner with folks like you in spreading the word and the importance to indoor air quality. And yeah, talking about humidification is something that's been in our industry for a very long time. And the interesting part to it is when you think about humidification, you either evaporate water or you boil it and create steam. And over the years of the production of products, not much has changed. So with an innovative product like we have rolled out over the last couple of years, it's important to get this knowledge out there for the benefits to the indoor air quality, for the homeowners and the occupants, obviously, to the level of understanding for our distributor partners and our contractors.
Saving water, like yesterday or the day before, I can't remember what it was, but you made a point to me that never really thought of before is like a homeowner. They go to wherever their furnace is installed, if they can get to it, their humidifier is installed, if they can get to it. Sometimes it's in an attic and they don't really go up there, but if it's in like a closet or a basement or somewhere that's accessible and they're walking by it and they hear water constantly running down a drain, well, they might be concerned and think that they're wasting water, their water bill is going to be high, and so on and so forth. So having a technology that actually uses most of the water in the process instead of dumping it down the drain, I think is something that probably a lot of end users may want when they're doing like humidification, because it's saving that resource as well, right?
Absolutely. And I was a technician for many years, and I can recall so many times homeowners telling me, you know what, don't even worry about servicing the humidifier. I don't even know if it's really doing anything. I hear all this water running down the drain. There was just a lot of challenges and, quite honestly, objections to what a humidifier is versus what it can do to a home. And it's that education standpoint. And through product innovation over the years, there's been different manufacturers, including AprilAire, that have tried to recoup water. We have a product right now today that uses 100% of water that goes into the humidifier. The challenge with that is it requires a lot more maintenance. It requires annual maintenance plus one. So you're going out there twice per season just to make sure that you're the water panel out, you're servicing the unit, making sure that you're not getting any bacteria or any kind of microbial growth. And that's often another spectrum of the humidification. Is there's a lot of perceptions that adding humidity is actually going to cause negative attributes inside the duct systems. And I'm not saying that's not going to happen, but when we properly install, service, and maintain humidifiers, they're one of the most effective products that you can have inside a home for the health and the comfort.
This is going back to last year. There was a post on Instagram, a humidification system that wasn't centralized. They ran water to these heads all over like a high-end home, and it would spray water out into a mist form. And most of the comments were like, it's a mold trap waiting to happen, or that's going to be like the Amazon jungle. And I'm thinking to myself, wait a minute, I've worked on this type of humidification system in commercial lots. And if it's controlled properly and you're putting out a cold mist somewhere, it's not going to create an environment that generates mold if it's controlled properly and it's maintained at the right levels. Some of these people have been in HVAC for a very long time. So I was a little bit withdrawn from some of the comments just stating this. I'm like, guys, if we control this properly, it's not going to be a problem. So it just goes to your your statement about in the duct and whatever, it's all about control. If we control it right, we shouldn't have any issues, right, Chris?
Control, operation, proper sizing, installation, and then most importantly, the service and the maintenance. And if you're a contractor out there, stressing the importance, well, let me even back up a step. When you're installing the humidifier, it's so important for our installers and our industry to educate the homeowner on the importance of the maintenance that is required. And with a lot of contractors offering service and maintenance agreements today, what we're starting to see is just a lot more inclusive selling with the maintenance contractor versus walking in the door saying, hey, I need to come in and service the humidifier and it's going to be X dollars more on top of your monthly payment. People are just starting to say, hey, I could walk in with that already a part of my service and maintenance contract. And the better contractors, they're including that in the monthly payment. So they're getting the payment, they're getting the revenue and the profitability that comes with it. It's just coming along with it on a monthly basis.
Okay, Chris. So you guys have AprilAire has a technology that helps to save on water, that prevents that trickling down the drain that we discussed earlier. Cool. Maybe let's dive into that a bit.
Absolutely. And we've had two models over the course of the last 2 years that we've introduced that encompasses this recirculation, or what we're calling the HydroCore assembly. Our model 720 came out in 2024, and that's our fan-powered evaporative humidifier. And then last year in 2025, we released the bypass model. And as I mentioned, that HydroCore assembly essentially replaces what we've all recognized as a water panel or a water pad over the course of the last many years of evaporative humidifiers. And what this HydroCore assembly consists of is it has a scale control insert, which is essentially the frame. It has a brand new redesigned distribution tray on the top of the unit. So that way we're more evenly spreading that water over the whole, we'll call it the water panel, but that HydroCore assembly. Then we have that HydroCore, and then we have a feed tube as well. So every year annually, this whole HydroCore assembly is going to be replaced. And the benefit to that is now we're minimizing any kind of mistakes on installation or the service and maintenance of a humidifier that would prevent it from actually working properly. Yeah, the technology is awesome in that we're able to reduce the water going down the drain while being able to increase the evaporative capacity or the efficacy on the output.
I mean, during a quick call with you over the phone, you mentioned something that I think is really important, is that over the last bunch of years here, our equipment has changed, right? And you even mentioned like lower plenum, like if we're using a heat pump, we might have a lower discharge temperature. You know what I mean? And that could affect it, because in the past we got this old 80% furnace. A lot of the heat is being driven into that bypass humidifier to evaporate the water, or if we're using a 90% furnace, it doesn't really matter. But we had more heat in the air and the supply to evaporate that water. Now with a lot of people transferring over to heat pumps and lower plenum temps, we might not have that heat in the air to evaporate the water quite as easily. So does this stuff help out with that the HydroCore technology? Does it help with this kind of stuff as well?
It does, absolutely. And that was one of the key indicators to drive towards the innovation, because as you said, the industry where we've changed the most is in our efficiencies of our equipment, going and trending more towards heat pumps or dual fuel systems, multi-stage gas furnaces, staged blowers, or even in ECM or a variable capacity blower. All of that has to be considered with evaporative humidifiers. You need three components for evaporation to occur. You need the heat content of the air, you need the water, and you need airflow. And if you put those three together, you're going to get evaporation. I mean, we can break it down to the simplicity of taking a bucket or a pot of water, putting it out in the room, and you're going to get evaporation. The higher the temperature, the water temperature also could be a key part to that, because we're talking about the energy now being utilized as part of the evaporation rate, and then the airflow. And one thing that I'll tell you all is that when you're looking at capacity charts for AprilAire across all of our humidifiers, we rate our evaporative humidifiers at 120 degree Fahrenheit plenum temperature and 70 degree Fahrenheit water temperature. So if we were to increase both of those numbers, we're going to get more effective evaporation. If we decrease both of those numbers, we're going to get a less effective evaporation. And that all has to be considered at the end result of the humidifier that's going to be chosen to be installed and operationally.
Let's talk about the installation of the water feed, cold water versus hot water. What are we doing there?
Before you have a recirculation feature, it was imperative, and you were installing on the return side of the plenum because that's the cold air side of the plenum. It was imperative that hot water was a necessity to help that evaporation process. Well, with these two new units and technology, we're essentially, as we're mixing and going back to your earlier question of how this technology works, once we have the initial call for the humidifier to turn on, our valve opens up and allows that water to go into the feed tube through the distribution tray and then start to cascade down the HydroCore. Well, what is a little bit different to that now is that feed valve, or the solenoid valve that many people are familiar with, actually creates a seat to the drain. There is a little overflow, but now what we do is we start to siphon, or a Venturi effect, of the recirculated water back into the new water that's coming in there. So that's what's allowing us to reduce the amount of water that's going down the drain, saturating that water paddle more and creating that efficacy. So using hot water isn't really a requirement any longer. It's not going to hurt anything by any means, but you can't look at it as increased efficacy today because we're using the heat energy during that first, say, 2 to 5 minutes of operation. And then it's slowly decreasing. That heat energy of the water temperature is decreasing because we're recirculating and using that heat through the process.
Something that I've never seen in the field or installed myself is the fan powered humidifier that mounts to the duct. Like, everybody's used to putting the bypass in between the supply and return. I remember I was at a home once and they were asking me about a humidifier, but the way the duct was done, it was almost impossible to cut in a bypass. It was almost impossible to even mount a humidifier on the duct to begin with. But to get a bypass in, it was almost going to be virtually impossible. And then I seen that AprilAire had the fan powered. I think the first time I seen it was at a local trade show here in Toronto, the Noble trade show. It might have been last year or the year before, but I definitely like the technology because it's one less step that an installer's got to do. It's one less cut into the duct that now we have to worry about and seal and make sure it's not leaking. So let's talk about this fan technology that cuts out the use of the bypass.
In the fan-powered humidifier, if you're going back into the history of model numbers with AprilAire, our model 700 has been our most recent fan-powered humidifier. And what the reason why fan-powered humidifiers really should be considered in your installations would be because of what we talked about. If you have a 2-stage or a 2-speed system or a variable capacity or modulating unit, your fan airflow of your system is going to be reduced, which means your evaporation is going to be reduced, right? In those cases, that's where I'd want to consider a fan-powered unit like the Model 720, because it's not really depending on the airflow of the HVAC equipment to create the humidity like a bypass would. It's got its own fan that's integrated, and it's going to draw the air that's in and then push it right back into the plenum and out into the home.
Yeah. Okay, cool. So that fan there, that's just, what sort of fan is it? Is it 120 volts? Is it like a smaller fan that's powered off a transformer? Like, how's it work?
Yeah, it's a standard 120 volt motor. It is a 2-speed motor, so there is a fan selector switch. Yeah, if you're in, so equipment manufacturers have done a great year of making furnaces very, very quiet. And what homeowners were quite honestly calling AprilAire and calling contractors and distributors were, hey, I can hear my humidifier running over my furnace. And we recognize that as part of the voice of the customers when we were doing the design of these systems. So what we did is we put a 2-speed fan in there with a little selector switch that you can now lower the fan speed, which also reduces the sound quality it reduces the efficacy a little bit, but it's still greater than our older generation evaporative humidifiers.
So if we were looking to pick and choose between fan powered and a ducted bypass, we would look to choose the fan powered as the example you give, where we have like a modulating system. We don't know what the airflow is going to be like, or the temperature of the supply and all that. That would be probably the best route to go, you think?
Absolutely, I would agree with that.
Now, the traditional bypass, talk about that, and why, now that you have the fan powered, why someone would choose the bypass over the fan powered one, knowing that it's an easier, like, there might be a difference in cost. I believe, like, I don't know these things, so that's why I'm trying to get your take on it. So if someone likes the fan powered unit, yep, it's a one shot deal. Mount it, put the control in, bring it power, and we're done. But other people may want to use the bypass still. So why would someone use the bypass or the fan powered?
I'm going to just speak to the fan power just for a second, and go into the second part of the question, because it's so relevant. With the fan powered humidifiers, to get the most efficacy out of them, you really should install those on the supply side of the system. But also, another challenge to the equipment is our cased coils have gotten so tall that our plenums are shrunk. So physically installing a fan powered humidifier on the supplies is really a challenge. And you can install the fan powered humidifier on the return, but with that cold air, you're reducing that capacity substantially. When we look at now, that would transition to your question, spot on. When I transition to the bypass humidifier, I can now pull that heat from the supply and increase the efficacy of the humidifier through that bypass model over that fan powered model.
Makes sense. So if you have a big enough supply, your coil is not too tall type thing, then the fan powered one would work if you can fit it on there. If not, go for the bypass and get that heat from the supply into your return. Is there anything else we can talk about as far as the technology? If there is, we can continue down that road. If not, I'd like to talk to you about humidification in general, and maybe even talk about steam and best case scenarios and best use for steam in that too.
I would just like to emphasize, when we're talking about the water recirculation feature and we're reducing water going down the drain, on the Model 720s, we're talking about a 60% reduction in wastewater down the drain when we compared it to our older Model 700. When we're talking about the 620, the bypass model, that's a 55% reduction in the water going down the drain compared to our old Model 600. One of the biggest thoughts or opinions that gets formed is, when we're talking about recirculating water, that we're holding in water in these units. When the humidifier has stopped operating, that valve that I talked about earlier, that was the supply or the solenoid valve, then opens up and all the water drains out of the unit. So the water is not being held inside any of these models for a long period of time in the off cycle that would create any kind of potential bacteria or microbial growth. I just wanted to make those 2 points out, because sometimes there's this opinion formed that when we're recirculating water, that we're holding water, or we're saturating these pads and holding water on these pads. We're not doing that at all with either of these technologies.
We've come a long way from the old drum style humidifier that used to did AprilAire ever make those back in the day?
We did not, no.
Oh, you didn't? Okay. Yeah, I've seen a few of those in my day, and they're always just caked with disgustingness. I don't even know. I have to send it to a lab to figure out what's on those things.
You don't want to know what's on those.
Let's talk about humidification as far as steam goes, because that technology, if you think about it, it does use every drop of water that goes into the cylinder, right? There's no water ever usually being wasted unless it's going to go through like a flush or something like that. One of the things with steam I'd like to bring up, and I may have asked you this last time we talked, but that was a while ago. So let's do a refresher for myself and the audience. Is with a steam cylinder, your steam cylinders that you have, is it conductive?
It is.
The conductive part requires the water to have a certain mineral content inside. A lot of people will say never soften your water or filter your water before it goes into your steam humidifier. So can we talk about that for a minute, if you don't mind?
I think the water discussion, quite honestly, can go back to the evaporative side and the steam side, because
Okay. All right.
To your question, well, let's talk about the steam side just so we're not creating any kind of confusion there. When we're talking about conducting, water is conduct, right? We know that there's minerals, there's metallic elements, there's all kinds of different components of water that make it conductive. Well, the more minerals, or quote unquote, the harder the water, the more conductive that water is. So you're going to get pretty quick escalation in steam production in those applications. And then vice versa. If you have softened water, you're taking some of those components and reducing them. And then if you have like a reverse osmosis system where you're taking all those elements out of the water, you're going to have a really long process of trying to boil, and because of the conductive elements that have been removed.